Welcome along tonight, and thank you for coming along on a warm night. And I put a special shout out to Kevin, who's NTAC normally, but travels everywhere because I keep following him on Facebook. So yeah, welcome Kevin.
Thank you.
Kevin didn't see this talk up in NTAC last time, so he came. You didn't come down just for this, did you?
Yes, I did.
You did? Oh, well, there you go.
You may
mention
in the broadcast.
And everyone told me how good Hayden's talk was, so I had to come down to see it.
This is actually slightly different as well. So you won't get the full, I had to condense it.
So, for those who don't know, this is Hayden, and everyone knows Hayden. And Hayden's been playing with VKLink, along with Dion and VK3s and all sorts of. Anyway, you'll go into that.
Dion's been a bit quiet on the radio front lately, but the VK3 has been. He's been around. So.
Okay.
Yeah.
So to talk to us about VKLink and voting and simulcasting, and he has also brought along some very impressive remote kit, which I suspect a lot of people are going to be interested in when they realise what it actually is.
Yeah, but not at the price.
So anyway, cross to Hayden, go for it.
All right. Well, thanks for coming. As I said before, I had to condense this down because it went for quite a while up in Lottie. But anyway, we'll try and keep it quick, and if I rabble on, then let me know and I'll skip it along. So voting and simulcasting. So what we're talking about is repeaters. So I won't go into what repeaters are. You'll know what they are. Speak on them. You can talk to everyone who can hear the repeater. But what we want to do is we want to make a repeater have the biggest coverage that we can, because we want to expand the conversation that happens on a repeater out as far as we can to as many users as possible. So the first thing that we do is we pick a good location, and usually here in Tasmania we find the biggest mountain that we can and stick a radio and antennas up on top of it, and it works pretty well. But the only problem is that with lots of mountains means that we have coverage issues, as a lot will probably already know that. So there's a few things that we can do. We can put a lot more repeaters in. We can use lower frequency. 2 meters propagates better than UHF. 6 meters usually propagates better than 2 meters, but there's trade-offs. So what we're talking about here is we're talking about the UHF frequencies with this particular presentation. So as I said, if we want to increase our coverage, we can put multiple repeaters in on different frequencies. We can, that way we have users which they pick which repeater they are in the coverage area for, and all of the users, they're all part of a conversation, but they can't talk outside that. So for instance, if someone's talking on RAF on Mount Faulkner, if I'm down in Huonville, I can't talk to RAF because it's not real good coverage down there. So you have that problem, you can't expand that conversation. And that's what we have already here in Tasmania. We have a lot of repeaters all over the place. Some sit by themselves that don't get used. So, but that's what we have at the moment. So the next thing we do is we link our repeaters to expand the coverage. So we install multiple repeaters and we link them all together, and there's several ways we can do that. A few listed there. We can use in-band linking, so we put another radio at the repeater, which then talks to the other one, and vice versa. There's various ways we can do that. We can do it over the internet. We can link to a hub repeater, so we have lots of different repeaters and they all link back into one. So that's what we had originally with Mount Arthur. We had everything linking into Mount Arthur. On Mount Arthur's frequency, 147 megs, So all these UHF repeaters all link back to the one. And again, if you know where you are, you pick the repeater that you're closest to or that you can hear the best. And everyone's all part of the same conversation, so that's brilliant. They can all talk together. The only thing with this is, with that situation, there's lots of different repeaters. You've got to know what frequencies they are, what tones they use, where they are, what the coverage is. If I went up to, Victoria and I was travelling around, I probably wouldn't know which one to use. So it gets confusing, especially for visitors. So then we move into receiver voting. So instead of having each person pick what repeater they use for the area, you can let the repeater decide for itself. So with receiver voting, you can balance the system by improving receiver coverage. So for instance, if we've got a noisy site, so for instance say Mount Wellington, we can put lots of little receivers in Hobart, in Norfolk, in Hilmville, in Kingston, and that balances the system out. Then what we do is we get all of these receivers and we link them back to the main repeater site, and we have to match the delays, the propagation delay from each receiver, because they're not all equal distance. The voter picks the best signal, and there's various ways to do that. The most common way is using a signal to noise comparator. So it looks at all the channels, all the receiver channels, picks the best one. That's the simplest explanation. And it does this lots and lots of times per second, very, very, very quickly. Just a quick point on the delay. The delay, all the signals have to arrive at the repeater site at the same time, because there's no point voting on a signal that's older than another one, because it'll be out of sync. So that's a problem that we had with IP, and I'll talk about IP a bit later. Not so much on RF. RF's limited by the speed of light, which is pretty fast, but not fast enough, as I'll show you later too. So it's all good. So we've got all these receivers, that's brilliant. But what happens when we're driving, driving somewhere and we're getting into the repeater fine, but we can't hear it? That's a problem. You can't. What do? You've got one big transmitter up on top of the mountain, but you're in a location where you're getting in noise free, but you can't hear what's happening. So that's where simulcasting comes in. So the main goal with that is that our users don't need to pick what repeater they use. They're all effectively linked repeaters, all on the one frequency. They all use the same frequency, hence simulcasting. You combine that with receiver voting and you've got one big massive repeater. So when I say about linked repeaters, I'm talking about they are in overlapping coverage areas. We want to overlap the coverage area. So if you're in a mobile, you're driving through the coverage from one repeater to another, you don't want to break in signal strength, so you want to overlap them a little bit, but not a lot. So the advantages are that everyone's on the same frequency at the same time. There's nothing to adjust. One channel. The repeater picks which receiver you're getting into the best, so you've got a good signal. As I said, overlapping coverage areas forms a virtual repeater coverage area that's larger than what we can get from any one site. So you can't get one site that's going to cover everything. Especially here in Hobart, it's pretty hilly here in Hobart. Launceston's a little bit different, it's fairly flat. You can cover a lot more than what you can down here. So we can create an otherwise impossible repeater coverage in the geographic area. So we can fill in all the shadows, all the holes, not so much here in Hobart, but if it was in the city like in Melbourne, we could put a receiver and a repeater in the middle of the city, which would talk to all the rest, and you could drive through the city and you wouldn't even know that you were on a different frequency. So that's all well and good. We can do all that, but there's always a catch with this. always a catch. So I spoke about that overlapping area. For this it requires very precise frequency control. We have to have no more than 1 Hertz of error at UHF. We also need very precise audio control, so we need to make sure that all the audio is in phase. The response of each transmitter is exactly the same. They all deviate up and down at the same level. They all have the same frequency response. If we're doing this using RF linking between all the sites, we need to make sure that they all have identical frequency and phase response. And the reason because of that is because of that overlap area. So, everyone's probably familiar with the capture effect on FM. So the capture effect basically is in your FM receiver, it will lock into the strongest signal that the receiver is receiving. However, if it can hear 2 transmitters, 2 signals on the same frequency, and they are within 83 microseconds at 1 kilohertz out of phase, then it starts to sound bad. It starts to distort, you can't hear what someone's saying, it tears. It's trying to think of how to explain it. If you've ever heard of if you've ever observed on UHF multipathing while you're mobile, you've probably heard that. Sometimes you'll hear the signal distort because it's reaching your radio via different paths at different times. That's sort of what it sounds like, but much worse. So we need to make sure that our transmitters are on the same frequency, exactly. So we do that through GPS, we can lock it to GPS. And that's where the speed of light comes in. So if you're closer to one repeater, but you can hear 2 repeaters at equal signal strength, then that's where you get that tearing and multipathing effect on the signal, and it's difficult to hear. So if you're in range of one or the other and you're getting a much stronger signal from one or the other, it's fine. There's no problems. You wouldn't even know that there's another transmitter there. So that's the problems that we have to overcome. Another thing is, usually when we're mobile, our frequency from our transmitters are not the same anyway because of Doppler effect. If the frequencies are exactly the same and they do match, then it can cause nulling, so the repeater will disappear completely. Not so much of a problem at UHF, at 6 meters definitely. But we're doing it on UHF, so it works.
So that was your wife, I don't know, you're only on 6 meters.
Come on.
That's a different issue though.
Yeah.
So we're not past said all that. So you sort of get the idea of what we're talking about here. So that's good. So how do we build it? How do we build it? How did I build it? Well, I got matched repeaters and modded them for external frequency reference. So I used the KL series. You probably saw that with Justin had the beacons, same radios. So I modified them to accept a 10 megahertz GPS reference directly. Link all those repeaters to one central site over a high quality audio path, so RF, IP. Use a signal to noise voter to select which one's the best receiver, and then you send that back out to all the transmitters. You put in the audio delays to make sure that they're all matched. Tune and maintain the system, and you spend money on it. Commercial systems, how much do you think a commercial system costs? I got a few different values, but I know how much it is now.
In Tasmania, hundreds of thousands of dollars.
Yeah, $1 to $2 million.
For how many repeaters?
For how many sites?
2 site.
So two sides?
For a 2-site system.
Right.
So it's about $1 million a site. Obviously, that's not what we're spending. But commercial systems, you know, they need to do it. The best example is the TFS pager system. That's, you know, huge. They use the same, or they use similar technique, but on VHF. They don't match the audios. They actually have a random phase. I can't remember what he called it, but when I found out about it, each site does not send its audio at the same time. It sends it randomised. But you know, they run 100 watts into a 6 dB gain vertical, so you know they're hoping that the pages hear one transmitter more than the other. But yes, it's expensive. So that's where we come into the RTC system. So currently it's a 2-site system, and they're both simulcasted. So we've got 2 transmitters, and they both run at the same time, same frequency, same audio, all at the same time. There is a backup failover, so if the connection between both the sites goes over, they can operate as individual repeaters, just local. They're GPS locked. The frequency and the audio are both GPS locked. They're all on the same frequency. Our receiver audio, our voter does the voting in 20 millisecond blocks, so it does quite a few decisions per second. That's quite a lot. So, and it's all done over VoIP using VKLink, and the voting's done in software and the audio is done in software too. And at the moment our sites are connected via the internet using low latency links. We don't have private IP links between the sites because we can't see the sites directly, and we also have restrictions as well. So that's Mount Wellington. The repeater controller's on the left, that's a Raspberry Pi. Running Raspbian? No. Raspbian? Yes. Cut down version of Raspbian. And we've got the rack on the right hand side. So in the bottom, I think I can point to it if I can. In the bottom we've got a MikroTik router. There's the Pi there. All of the workings and boards and everything is sitting in this rack case here. GPS and our radio on the top. And this is the Grey Mountain site. Same sort of thing, only we don't have a really good rack there. We've got to upgrade that. But yeah, same setup there.
Where's Grey Mountain by the way?
Grey Mountain is closest to Signet.
Right.
So it covers the Huon channel.
Right.
So that's now on the same frequency as RTC?
Yes.
Hmm?
Yeah. Exactly the same frequency. So, so that's all good, but what we need to do, we need to GPS lock everything so that it's all in phase, it's all in sync. So what I did was I got the KL450 UHF transmitters, and they use that PLL, and usually they're locked to a 12 megahertz TCXO. It doesn't have the stability we want. If it was within its rating, which it's not, it moves more than 2.2 hertz. Depending on how warm it gets in the radio. When the radio starts transmitting, it gets hot, drifts. So we needed to change that to work with 10 megs, which is the GPS standard. So what I did was we hacked the PLL software to make it work. We just put in a divide by and it just works. So it actually works on 10, 12 and 14.4. I tested the channel spaces that I wanted to work on that. So I removed the TCXO, just directly injected straight from the GPS, and it worked. So I used the VG7TBL GPS unit, and that's good because it gives us 10 megs and it also gives me the 1 pulse per second for the audio timing. I think Rex, you used one of those GPSs as well for your stuff, with the green boxes.
No, I gave it away.
Did you? Yeah.
Traded it.
They're not quite on 10 megs.
I traded it for a 10 gig for you.
Ah. Yes. So that's all good. So we can GPS lock everything, but the problem is we still have that delay problem. So I didn't have delays. I couldn't, if we linked the sites via RF, you need lots of radios, lots of antennas, lots of coax. You need to put delays in the audio between the sites. I didn't have delays. We're talking microseconds delays. Didn't have that. In the end, come along the RTCM voter solution, which was using VoIP. So what that is, it's a VoIP solution. It connects all the sites together instead of RF. It uses the internet or IP. It's open source. It was designed in 2011 by an amateur who passed away last year, Jim Dixon, WB6 something. He did a lot of stuff with All Star. You can buy these boards in a commercially made form, $350 Australian. I wrote that, probably like 400 now. Or you can build the original prototype board, which operates exactly the same. Only it's a lot bigger and you need to populate it. So I managed to get 5 PCBs made from China. China's fantastic for that sort of stuff. Got the parts. So instead of $350, I managed to make each board for $150. So quite a big saving. Took about 8 hours to populate, but that's okay. I don't charge myself for labour. So each board interfaces to a receiver and a transmitter or both, and then that board connects to a host running app RPT, which is a repeater controller within Asterisk. So Asterisk is PABX, handles calls, and the repeater app RPT basically just interfaces that to a radio. Is probably the easiest way to explain it. So pretty much it's just All Star basically. If you're familiar with All Star, that's what it is. It's just a cut down version of All Star, so it runs on the Pi. So that's what VKLink is. Yeah, so it's a cut down version so that it can run smoothly on a Raspberry Pi. VKLink was originally developed to link repeaters over the internet using high quality audio. That's all it was ever designed for. It just so happened that the channel for voting was actually left in by Matt VK3VS. He left that in there, so it works with the system, which is fantastic. So I was already using VKLink to link the repeaters in Hobart to Launceston. So yeah, it just seamless, just straight. I didn't have to do a lot. So before we go to the next slide, before you go, I'll show you this. This is a receive only setup. So basically what we've got is we've got a KL450 receiver. I've got a voter board which I built up. It's connected to a GPS, power, and and LAN for your internet, and that's all it is. So that's a receive only setup. The transmitter's got a lot more. Once you add the transmitter, you've got a lot more equipment at the site. But I'll pass that around if you want and have a look. So more about the VKLink system. I actually wrote an article for AR, submitted it. So that'll be coming out. There's a little bit more detail in there. I won't go into that detail. But basically, it's Raspberry Pis. They all run VKLink. They connect directly to each other over IP using a UDP port. All the audio is done in Asterisk. The radio controlled by app RPT. The radios that are hooked up to the Pi are usually interfaced to USB sound card fobs or Pi's GPIO pins. So there's many different ways you can interface to the system or to radios. So this is really good for repeaters that don't get utilised a lot. It's an on-demand. There's two modes of operation. There's an on-demand linking, a bit like VKLink, where you dial in the number, dial in the node number, or there's a permanent. We can set it to permanently link a repeater, and if the link goes down, it will automatically come up when the internet comes back up, or power, or whatever the case is. So it's very good for repeaters that get underutilised, and you can link in and out. That's how I had this sound card fob and a Pi connected to the 10 metre repeater. When there was activity on the 10 metre repeater, I linked it into the UHF system, and no one probably knew. So there's a picture of the commercial board on the top left hand side. It's all nice in a nice case, but it's expensive. Mine's a bit more ugly, but I'm not really worried about saving space. So to put it all together, we have a receiver, optional transmitter at each site. They're all connected to a voter board with a GPS. There's a master site, which is a master timing site that's used as a reference to all the others. That site has the repeater controller at the site. The GPS provides us 10 megahertz reference for the transmitters to lock the frequency. And the 1 pulse per second is for the receiver audio timing, to make sure that that's correct. Audio is then sent from each receiver at each site to the controller, and then back out to the transmitters at exactly the same time, and I can adjust that down to 200 nanoseconds using that board. So to do that, if say Mount Wellington's closest to all of our users in Hobart, Mike, who's sitting over on the eastern shore, starts sitting and hearing both transmitters, and it starts to get, out of sync and noisy. I can adjust the timing on so that Mount Wellington's signal is delayed because it's closer to Mike than what Grey Mountain is. Luckily here it's a bit of a not a two-edged sword. What's the word? Where it's bad but it's good. I can't remember. Anyway, it's good that we've got mountains and hills, and it's also bad. It's good because you can place your repeaters in a place where they'll cover one area but they won't cover the other. So they'll be blocked because of terrain. So you can utilise that to your advantage. IP latency. So you've probably been using the repeater and been wondering why you hear yourself come back the last few seconds of your audio. The problem is the slowest receiver, audio-wise, you have to account for that. So you have to have a buffer. You have to get all the audio from all the sites before you can evaluate it. That's why there's a buffer. Otherwise, if you evaluate it before some audio's arrived, you'll get choppiness, breaking up, the normal sort of stuff. Unfortunately, well, not unfortunately, it's the only way to do it. The protocol that the guy developed for this runs over a UDP port, so it's basically once you send it, you can't acknowledge that it got it. That'd take too much time anyway. So it's basically send it and just hope for the best. But luckily, because of low latency links, it works. If the buffer value is too high, that's why you get more of your audio coming back to you. If the buffer value is too low, you get choppy audio. So there's a bit of a compromise there. I can lower the value a little bit more, but it'll never be perfect, and that's just one of the drawbacks with IP. You can't do a lot with it.
At least you can tell what your own deviations are.
Well, yeah, and it can be an advantage. Like if you're mobile, you can tell if you're getting in okay. The simplest way is to wait maybe a second before letting go of the button, and then you won't hear yourself. If you turn, the repeater actually encodes tone, so if you turn on the tone decoder, it takes a while for the tone decoder in your radio to decode the tone, so the audio won't open up on your radio. So that's another way you can mitigate it. I have noticed with this system occasionally there must be an internal buffer. I've got to go through the software and have a look, because it's all open source, you can just look through it. But I've got to see, I think there's an internal buffer in there that varies up and down, because sometimes you'll let go of the button, you'll get a second of your voice. Sometimes you'll let go of the button, you get 3 seconds of your voice. So I don't know why it does that. I've got to talk to in America it's big, All-Star's huge in America, so there's a lot of support over there. That actually leads well into the next slide. So that's all good. The other issue that I had was that board there has a reference as well. One of the little crystals, 9.6 megahertz. That crystal is 25 parts per million, so it's nowhere near stable enough for that. Our audio would wander all over the place. So I had to lock that as well. So because it's 9.6 megs, we can't just easily divide it down to 10 megs. The PIC doesn't allow it. They tried when the guy was developing the board, just couldn't get it to work. So I just so happened to come across a YouTube video of a amateur in America, Joe KC2 IRV, and he was doing the exact same project as me, using the same equipment, except for Kale. So basically he had the same problem, so he designed this board which is pulled out of a Motorola base unit. It basically gets the GPS signal, gets the GPS signal, divides it down, then compares it with this OCXO, and then adjusts the voltage control pin on the OCXO until they match. I think that's how it operates. So that was good. That allowed us to lock to 9.6 megs. I did try just with this OCXO by itself. It does work, but the audio does drift around over time. It's not 100%. So locking it to GPS is the easiest way to fix it. So there's a picture of what's in the rack. So we've got that board on the left and the Voda board on the right, and all our connections. We've got LAN, tone decoder for the repeater, GPS, power, and that's our GPS in for this board. Now some of the cool stuff we can do, I can view the signal strength in real time. Someone's talking on it, so as we increase our sites, that'll increase the amount of information that we get. So obviously when you watch this in real time, the bars are moving, going up and down as the person's maybe driving along, or if they're stationary, it's pretty stable. Currently I've got Mount Wellington as the master site, with Grey Mountain as the secondary site. So that gives us a bit of information. I can also monitor all of the nodes, what's connected to what. I can connect it on demand using the net. I can see the uptime, how long it's been connected. This actually changes colour, so when someone's transmitting on one, it lights up blue, disappears. So that's pretty cool. I can also pull the received audio from a repeater, from all of the receivers, and I can evaluate it later. So if a repeater site's really noisy for some reason, I can find out where the person was by listening. So this is actually an audio recording. So as it plays, these are 20 millisecond blocks of chunks of audio with the received signal strength from what site. I can also force the site as well, so it's pretty cool.
So you are actually using Mount Lloyd as one of the receivers?
No, that board there is actually Mount Lloyd. Mount Lloyd's being used for a different purpose, and I'll get into that in a minute. That actually is going to be Mount Nelson, because I want to cover the outlet, because I travel it every day and it frustrates me that I can't talk on a repeater when I'm in the middle of the outlet. It only takes 5 to 10 minutes to drive the outlet. It annoys me. So that's going to turn into Mount Nelson. And it'll probably be a receive-only site for starters. There's one small section along the outlet where the signal drops out completely, but apart from that, it's about. If you've ever driven in a noisy area, and you're listening to someone, you can still hear what they're saying as long as they're noise-free. You can hear what they're saying. So, for the 5 to 10 minutes, it's probably not worth building up a massive transmitter site for it. Too much trouble. So that's the current. That's the current coverage. Green being really good, yellow being marginal. For some reason, Radio Mobile, which this was done in, doesn't plot Hobart very well. That's why Hobart's in one big sort of a yellow half circle. It must be the mapping data or something in the software. But rest assured that's green. That is the planned coverage. So if we were to add Mount Nelson and we were to add Mount Lloyd, we would mainly extend up into the Derwent Valley, a little bit up the Midlands.
Isn't that the same problem that TV signal has? The land drops away so quick that the propagation can't come down low enough. The angle of
Yep.
flow is outwards and not down.
Yeah. Interesting story. I'll deviate off the point for a minute. Interesting story. How many have had in the past issues receiving, I think it's ABC in Newtown.
North Hobart, Newtown.
North Hobart, Newtown.
Yeah, the ABC DAB
Yeah.
is some DAB, so ABC Digital TV in that North Hobart to Newtown area, terrible.
Yeah, I might be wrong, but I think it's because of the pattern of the antenna when they put it in is wrong.
The antenna
There's
that
a
they
null
had
in
up-
that direction.
the antenna that they've had up since the installation of that mast has been dreadful,
Yeah.
and it became very obvious when the digital television started operating. That problem's being fixed with the new antenna.
At the moment, our antenna on Mount Wellington has it's a high gain vertical, which you'd think is not really good because the majority of the pattern goes to the horizon and not down into the city. But the antenna's got electrical down tilt in it. I think it's about 3 or 4 degrees down tilt. So instead of pointing at the horizon, the main lobe's moved down. So
The people in up in the top of Mount Stewart, they have all sorts of problems trying to get signal off the mountain, so they go across to Government Hills
yeah,
and get signal out of that. But that goes right back since it was first installed. They used to come up with all sorts of crazy ideas to get the signal to bend down or put extra gain in the antenna or tilt the antenna at an angle. I've seen the antenna is actually pointed up like that, trying to get the signal that might drop over the edge of the hill that's in front of it. It doesn't usually work.
No, I mean you can put mechanical down tilt, but the problem is especially with an omnidirectional antenna, is half your signal starts to go to the sky off the back of the antenna as well.
Yeah.
So that's why we've got electrical down tilt, so that it tilts it in the E plane. Is that right? Yeah, I think so. So yeah.
I have heard that when they put the new antenna up, they bought a cheap band 2 frame to put band 3 elements on. So there were null points, and funnily enough, one of the null points came straight through to the ABC building, and at the ABC building the signal response wasn't very good at all. I spent quite a bit of time travelling around with a national Canberra-based guy doing checks on SBS and ABC, and it was woeful in places.
Yeah, I'm not sure. I think they've removed that antenna because they're doing work up there at the moment for DAB. They've removed it.
They're in the process of refitting the television antenna.
Yeah, I did this about 10 years, 15 years ago now.
Oh, and to clarify too, so our Mount Wellington site's not on the ABC site, it's on the wind site.
Yeah.
And we don't have an antenna on the tower. The tower's not for anything else other than wind. So we've got an antenna off the building. So that, because of the way Mount Wellington is, where the wind site, it's good for the northern suburbs, but it's not so good towards Kingston because of the rise in the middle of the mountain where the trig point is, which is the highest point. So that's why it's good for Grey Mountain, because Grey Mountain shoots up this way, whereas this is sort of, it covers it, but it's not as good. So we don't get that audio problem, we don't get the overlap issue, because the signal's a lot stronger from Grey Mountain than, say, Kingston, than it is from Mount Wellington. So, yeah, even though you can see the mountain, doesn't necessarily mean you can see the antenna. If you're in the northern suburbs, you can. So, future with this system, from the bottom to the top, expand the RTC coverage. We can fill gaps. If we could get a site up the Midlands, we could fill the gap near there. Oatlands is a little bit patchy, so we could probably almost cover all the way up the Midlands Highway, and once you get in towards Launceston area, you just switch to RAA. Another interesting thing, so going to the top now, we could do this on 6 metres, which would be very interesting in sporadic E-season if say a mainland station was hearing both transmitters at the same time, and I don't know what it would do. I don't know whether they'd be able to work it out, but one good thing is I've got remote control. I can turn off the transmitter if I want to. I can turn off the receiver. I can turn it all off. I can turn it all back on. So we've got that control. 10 metres would be good for voted sites, not so much for a transmitter, because I think it would just sound horrible having multiple transmitters on 10 metres. Especially if we ever get back up to the top of the solar cycle. I can only imagine long short path, that would really be interesting. But 6 metres, they've done this in America, 2 metres they've done it on. It works on 2 metres. You don't need GPS locking because the frequency is a lot more stable. 6 metres, I haven't seen anyone do it on 6 metres yet. But yeah, I mean, I really love 6 metres. If anyone realises, I really love 6 metres because there's all forms of propagation with it. So it goes pretty good too in our coverage area. You know, our healing coverage area, 6 metres just goes over the mountains a lot easier than UHF does. But that's in the future. But one interesting thing about 6 metres is we could have diverse any of these bands, but 6 metres in particular, we could have diverse receivers around the entire state tied back to one single controller. Because if you think about this internet, the system that I've got at the moment, the repeater site on Grey Mountain goes via the internet to Melbourne, then back to Hobart, because it doesn't peer locally. There's no peering in Hobart, and they're different providers. One provider's Tasmania, and the other provider's not Tasmania. So if they were both Tasmania, we'd be good. We'd be all in the state, and we wouldn't have to worry about that. But the good thing is this all works, even though that extra latency is there. It's only about 50 milliseconds. It's not a lot. So what you could do is effectively, if you've got internet at any site in Tasmania or even on the mainland, you can connect this into the same system. If you space out your transmitters well, you probably don't even have to GPS lock them, because one user, say in Burnie, won't hear the other transmitter in Launceston, and vice versa. On 6 metres, it's particularly interesting because if you have your transmitter in Hobart and you have diverse receivers in, say, Burnie, and Launceston, and Central Highlands, and someone's talking on it on sporadic E, they could be on any one of those receivers in the entire state. So, yeah, it's just interesting.
And to think about it, we'd have coverage on one frequency statewide.
Yes, that would be the ultimate goal.
Think about it.
That would be the ultimate goal. Someone could come off the boat
Correct.
in Devonport, turn on their radio, and they wouldn't have to touch it.
Correct.
All the way across the entire state. They wouldn't have to. Paul Roger, ARN's nice A4 repeater map would be redundant, but yeah. When I did this talk in NTARC, there was a VK3 guy who was he was interesting, but he said that a lot of VK3s, they say that our system is really good, and not just this system, but all the repeaters around.
Coverage.
Yeah, the coverage in Tasmania is really good. And of course, the reason I did it on UHF2 originally was to promote activity on the UHF band. It was an underutilised band. We lost 420 to 420 to 430.
Yeah.
So we'll use the bits that we're not using. 2 metres is a band that commercial services don't really care about, I suppose. It's only 4 megs. They don't care too much about it. UHF, there's a lot of spectrum there that they would really like, so we may as well use it while we can. Same with 6 metres, it's underutilised. The top end is 6 metres, so that was the whole reason for that. So yeah, that's about it, unless there's any questions. Or have I spoke too much?
I think we should say congratulations. It's an amazing task that you
Well,
started on
it's-
and what you've done.
It's not just me. There's a lot of people individually. The 2 people that I could think of the most is Michael, 7MRS. We've got this deal, unofficial deal, that I do all the electronic technical bits and he does all the mechanical bits. So I say to him, hey, I want a bracket for an antenna, and he goes and makes it.
Yeah.
So that's good. The other one's Murray. Originally, ZMS Murray.
Yeah.
Originally, the whole way I got into repeaters was I lived in the Huon Valley, in another valley in the Huon Valley, which is even worse, and I had no coverage. I had Brian BW and Peter TPE and Roger ARN come to my house and install a Yagi on my roof when repeater 2 used to be on Guy Fawkes Hill to get into it, and I thought this is ridiculous, so I decided to go and build a repeater. Fast forward a little while, trying to find a site. Murray managed to get us a site on Grey Mountain, and it sort of went on from there. So that now covers the Huon Valley from Kingston all the way down to Cocker Creek. So, Bruny Island, all those sort of places.
Murray's been much more active on the marine bands than he has been on amateur.
Well, Murray,
I've spoken to him a couple of times.
Murray, when we I've got to be careful because this is on YouTube too. Murray's going to watch this later. Murray, when we originally put the repeater in, didn't have his call, but I sort of got onto him a little bit and said, "Come on, get the call back," and eventually got his call back, and now he's doing 1296
And back active again, well and
doing
truly.
everything. So, yeah, it's fantastic. So.
And soldering as well.
Yes, he loves soldering, so it's good because every time I need to do something on the tower, I say, hey Murray, do you want to do some soldering up Grey Mountain? Yeah, no worries, cool, I'll go climb the tower and you go do soldering. No, it doesn't work like that. But yeah, it's them 2 guys have been good. But there's been a whole bunch of people, it's not just me. So Joe sent me all the radios, well not all of them, but sent me the majority of them. Joe's been pretty good. Yeah, otherwise it'd be almost impossible to do this, to get equipment that's all the same. Yeah, it's been a bit of a project. And I did have the question asked to me, why did I do it? And I said to the person, why not? Because it's a new thing. There's no other someone can correct me if they think I'm wrong, but there's no simulcast amateur repeater in Australia, apart from this one. This is the only one. There's one other voted system, that's VK3 10 metre repeater. That's got voted receivers on 6 metres and 10 metres. He does it all over RF, but he doesn't simulcast. So this is the only simulcast amateur repeater. There's plenty of commercial ones. They've got plenty of money to do that. But yeah, so something new. It works. So yeah.
I didn't even realise the Grey Mountain wasn't Grey Mountain anymore.
Well,
so it's obviously working well.
Well, that was the next thing. The quality of it surprised me. I didn't think it would be that good. The thing about simulcast is you will never get it perfect. You will never get it perfect because in the real world, if it was in free space, you can probably get it perfect. But in the real world, you can't get it perfect. So you fix one area, causes another area to be bad. You fix that area. So what you've got to do is you've got to minimise that overlap area between the two transmitters. And the easiest way to do that is figure out where a majority of your users are and tailor it to them. If you're in a car, mobile, who cares? Because you wouldn't know the difference. It's mainly base stations that you need to work on, and you can mitigate the issues by antenna patterns and geographic. So you can do that. You'll never get it perfect, but it's pretty good. It's pretty good.
You were quoting $1 million per station before. You said you got the cost of wards down and populated the controller. And what's your station cost?
Station cost?
Yeah.
As in?
The entity matches the $1 million jobbies. What's your...
Oh, compared to theirs?
Yeah.
Well, it's hard to say because I don't know how in depth their simulcast systems are. They can probably do a lot more with it, but effectively working on in the real world working, it's probably working just as good as theirs. And in fact, that system there, this board, that board there is also sold commercially for that very purpose, so that commercial entities can come buy that and build a system for a fraction of the price.
And by the time you put together the base radio, the various repeaters, the controller, the linking, the GPS, mast and antennas, what's that kit worth?
Oh, okay, I see what you're saying. So, off the top of my head, it's probably, for a full transmit receive site, including everything, antennas, cables, everything, it's probably just over $1,000. Probably just over $1,000. A lot of the stuff I've personally been given, or I've got at a very cheap price. So it hasn't probably cost me personally that much over the years. It has, but yeah, it's probably about just over.
Do you need a diplex for each side?
Yeah.
So that
duplexing.
That costs you.
Yeah. So another reason I did it on UHF too is because at VHF duplexes are very expensive and they're much more difficult to build. 6 meters is very easy.
Yeah.
2 meters is difficult because of the spacing, 600 kilohertz spacing. You've got to build the cavities and it's a lot of work. UHF you can buy notch filters. On Grey Mountain we run a band reject, band pass, which is a Motorola, which Joe gave me 10 years ago. The one on Mount Wellington is a band pass, band reject Decibel Products model, which cost me $250. So I've only paid for one duplexer in this system running at the moment, but I've got more at home. So, yeah. Now that I think about it, it's probably more like $1,500.
Yeah, but still 2 or 3 orders of magnitude less.
Yeah, it's like, you know, 100,001 or something like that. It's
Yeah.
more than that.
Any other questions for Hayden? Can we show our appreciation?
Do you want me to move on to the next one? So, this was the other thing.
Trent.
This is the remote rig. Basically what this does is connects in this setup, it's an 857D Yaesu. The head is here. It's connected to this box, and then the body of the radio is up currently on Mount Lloyd, and that's connected to, at the moment, two 2-metre Yagis. One's pointing north, one's pointing west, selectively. And this allows us to remote our rig to somewhere that's less noisy, better location, using the internet. So this would be good. You're probably familiar with Ham Radio Deluxe. People use Ham Radio Deluxe, and what's the other popular one? Can't remember. But this allows you to maintain the feel of that you're still operating a radio because you've got the control head. It's not limited to radios that have detachable heads. You can use any Yaesu radio that uses cat commands. Any icon that uses, what do they use?
CIV.
Yep. You can't use this for an IC7000 with a remote head because the remote head signal is an analog video signal. So you can't use it with an IC7000 in this configuration. You can do it in a different configuration. So another way you can do this is you can use one of those the contesting stations, the FT2000, with all the bells and whistles. You've got one here, and you've got one up on the mountain. You can actually control it as if you're sitting in front of it. Very expensive way of doing it, but you can do it. So basically, this box in its configuration at the moment sends the commands down into the box, which is connected via IP to the other end, and changes frequency, does everything that we do normally here. So this radio is actually tuned to the VK3 beacon at the moment on 2 metres, and it's quite strong, or it was stronger earlier. But I got this product because VHF propagation is very poor down in the valley. The Mount Lloyd site was being underutilised, so for the summer I decided to put a remote station there, see who I could work. So far I've worked VK3 on voice, VK5 on voice, ZL half copy on voice on 2 metres, and in the times that I'm not using it on voice I run Whisper. So I just run Whisper, I've been copied in VK6, 5, 3, 2, that's all, 7. So yeah, it's pretty cool. Very expensive, very expensive. These come as pairs if you want to run it in the remote head situation. About $700 for a pair. Expensive, but the advantages are that you can put your radio wherever you want, and you can still have that feel that you're operating a radio. And the audio, it uses about 1 gig a week on the codec that I've got it on at the moment. You can change the codec, but 1 gig a week's nothing really, so you could run it on a 4G connection, 4 gigs. You can run it on a, solar power site somewhere in the middle of the bush with a big HF antenna, 160 metre full wave loop. And yeah, it'd be really good. I've been contemplating remoting my entire setup at home because I live in Ranelagh, which there's quite a few houses around. If I can remote that up on my parents' house, which I've got a point-to-point link to, so I don't have to use the internet, they're a lot quieter. They're away from everywhere in the middle of the bush, up on a hill. So yeah, but yeah, it's pretty good. Pretty good. There's a few quirks with it, but it works pretty good. You can just buy this box and you can buy these boxes in a pair and still run Ham Radio Deluxe to control the rig. You don't need a remote, that's for the non-remote head rigs. And the audio gets passed through this box. The advantage with that is that you don't have to set up Skype to do all that, and you don't need a computer at the remote end as well. So you could just run this instead of a computer. You can also run one of these at the remote site, and you can have, they sell a USB dongle which has got a button on it for PTT, and you connect a headset in. And you can run it from your computer and use Hand Radio Deluxe to control it if you want, using cat commands. There's all sorts of stuff you can do. Unfortunately, the guy who developed it is from Sweden, so he doesn't document his stuff very well. You've got to go through each bit. The manual's about 200 pages long. If you read the manual from A to B, then you can set it up. It's fairly easy, but yeah, there's a lot of stuff I had to look up. But it's relatively easy to get going.
It's sounding virtually noise-free at the moment.
Yeah, well, it's nothing on the S meter at the moment, but see, it's a quiet site. And that's about, I don't know, 600 k's, 550 k's, something like that. I'll put some photos up of it. It's a 7-element Yagi.
Hang on, I'll switch it
sorry.
back on. No, that's alright, I'll switch it back on you.
If I have photos. Yes, I do. I'll upload one more photo. So it's not limited to VHF, UHF. If you've got a remote site that you want to run HF off because HF's too noisy at your location, you can do that as well. I just happened to have a site that I had access to that I could do this on, so. That's what I did. So that's a view from Mount Lloyd. So that's looking north is that way, west is out this way. So it's got a pretty good horizon, pretty good takeoff angle. I don't have a photo on here of the other direction, but it's pretty good.
What's the power up there? Is it?
I've actually got a. Oh, do you mean the power of the radio or?
No,
It's mains power.
It's got mains power.
Mains power. Yeah. This system's not on battery backup at the moment, but I don't really care about that.
Yeah.
But yeah, it's mains power. So the bottom, these two Yagis I built myself. They're YU7EF 7-element designs. I've been experimenting a lot lately with LFAs. I've built 2 LFAs for home.
Okay.
The LFA is just streaked better than what I had before. Low noise. Maybe not in all situations, might not be better, but in mine it was much better. But at the time I built these, so yeah, one's pointing north, one's pointing west, one's pointing north. At the top, that may be of interest, that's an ADS-B receiver. 1 gig, so we put that up there as well for fun.
Get any lightning strikes?
I'm not too concerned about lightning because this is sitting next to a 25-metre tower, something like that, right next to it. So I'm hedging my bets that the lightning's going to hit that first. If I get if I do have a coax switch up there at the moment, what I want to do is I want to reconfigure the system so that I can isolate the coaxes into a dummy load or a load that's not the radio. But we don't, in southern Tasmania, we don't have enough lightning to really worry about it too much. If it was in VK4, I'd be petrified.
Or the northwest coast.
Yeah, but down here we have hardly any lightning, so I'm not too worried. It's only an 857.
We had a good run on here on the main a few
And
months
remote.
ago.
Sorry?
We had one here on the domain a few months ago, and Barry was out in the new building and I was in here. And it frightened the bejesus out of both of us. I don't know how far away it was.
The other issue
It was
too.
virtually in the backyard here somewhere.
The other issue too with Mount Lloyd is it's one big rock, so it's hard to put down earthing and mat and stuff. So yeah, try not to put too many earth points down either for earth potential if it changes when the lightning hits at a distance. So,
Did they improve the vehicle access up there?
sorry?
Did they improve the vehicle access up there? When we were doing the rallies up, we were doing the valley, to trip up Mount
I
Lloyd.
can get up there in my
Isn't it?
forest.
Hasn't changed in a long while.
I can get up there in my forester. It's just the last bit. If it's snowing or it's wet, because it's on a rock.
Any cold weather, it was a no-go.
Yeah, you have to walk the rest of the way. But yeah, no, it's the road's okay. And last photo. So this is the rack. There's a lot going on there at the moment. It's not very neat. So I've got a PA up. So I've got a PA up there, so I can do 160 watts. It's set at about 50 at the moment, I think. I didn't bring my test set to see. It's about 50 watts. The 857, so that connects into the radio end of the remote rig box, which looks the same. This here is a very dodgily put together but working relay board, so that I can switch a coax relay and a power relay for the PA and a power relay for the 857. Because the 857 has a quirk that sometimes it can lock up, and unless you pull the power out and put the power back on, it won't come alive, and it's usually associated with connecting using the box. So when it goes to connect, it must not like it sometimes. So that's why that's there, so that I don't have to drive 200k round trip to reset power. And I've got that other one for the PA if I just want to quickly bypass the PA. This is all stuff from the repeater that used to be there. GPS, this is GPS locked too for Whisper. So I didn't want any drift, so it's GPS locked. I use an XREF in the 857. Unfortunately, Dave 3HZ doesn't do them anymore, but I'm looking at getting a Leo Bodner PLL unit, which is a programmable GPS that does everything from 800 and something kilohertz to 400 megs. So you can put whatever frequency you want at plus 10 dBm maximum, minus 10 dBm. So it's coming out next year. That's S6 now. And a PC to run the digital modes, because if you run the digital modes back to here and pipe your audio from here back, the timing can be out. And because of the jitter on the internet connection, if it jitters, it might not decode the signal properly. So I just put the computer there, connected directly into the radio. I don't have that problem. So the good thing about that is that I can log in and I can run stuff like stuff like spectrum mode. And I can view weak signals. So, yeah. So if you got a spare $700, buy one. Because they work really well. Yeah. I wasn't going to go put in HF. It probably would be a good HF site, but there's not enough room for HF. Plus, I didn't want to attract the lightning with a bigger antenna. So, as you can see, that's quite strong at the moment. In actual fact, if we called CQ, we'd probably find someone on 144.1. We'd probably even get Rhett and VK3 to pop up, and you get a response. So that's very strong at the moment. And VK3 has been really keen on this because he's been using it as a beacon and measuring the signal strength from it on Whisper and plotting it on a diagram, and then looking at the propagation effects. We've got a path on Troposcatter, so he's there almost all the time, and then he views it when a duck comes in. He views the signal come up and he plots that, and then looks at the weather patterns and does all sorts of things. So, I got an interesting Whisper signal through to Lee VK2KRR today. He decoded me at -28, and beaming south, he beams through 2 gum trees and a rock at Wagga, or near Wagga. And he said he's never worked VK7 on 2 metres in any form.
Yes, it has.
Oh, apart from
Meteor
scatter, yeah, but not on Tropo. No. And the spray key's too short, so he was quite thrilled with that.
Cool.
But the next step, I'd like to get a rotator up there. I want to get a rotator and along the Yagi, see if it survives winter.
You need to talk to your hardware guy.
I need to talk to my bank. Well, actually, that's not true. I've got to talk to the missus who's actually the bank.
Don't we all?
Yeah. Yes. If you ever want to meet someone with patience and someone who's puts up with a lot.
Long suffering.
Yeah, long suffering.
My wife's the same. Perhaps they should get together.
While I'm singing the praises, there's my LFA. So my LFA on 6 metres, which I built, and my 2 metre LFA I built. The 2 metre one I built, I took the design of a YU7EF 10 element Yagi that had suppressed side lobes, because I had an issue beaming at ZL where I had a lot of noise with my split dipole YU7EF. So I took his suppressed side lobe version in the hope that it would eliminate a lot of the noise apart from where I'm beaming. And what I did was in MMANA, which the guy who does LFA's G0KSC, Justin in UK, he says you can't use MMANA because it's not real world, it's not an NEC4 model. But anyway, I did it anyway. So I took the YU7EF, I put a loop on it, I then optimised it, put an extra element on and adjusted the elements until I got a good SWR and a good front to back and a good suppressed pattern. I got slightly better than YU7EF's theme, ever so slightly, and the good thing is I've got a loop which is low noise, and I put it up and my noise issue to ZL has cured. It has actually moved the noise to ZL's on a beam heading of 90 degrees. It's moved the interference now to 60, which is out in the middle of the Pacific Ocean. So, Pacific Ocean? Is that right? Tasman, yeah, up that way. So I wasn't really too worried about that.
And the design out of MMANA translated into the real world?
Yep. And
cool.
So what I suspect was happening with the YU7EF was I was getting a pattern distortion with the pattern, because one thing I did improve too was my Ballon design. One thing I researched with those two is they're almost a self-balancing antenna. They're more self-balancing than a Yagi, split dipole Yagi, because in MMANA you can model currents on boom supports, on coax, on everything, so it's like a blue wavy line. So I modelled the split dipole Yagi, which had large currents, common mode current, on the feed line and on the antenna. Then I compared it with this, and the currents were much, much smaller, which means that you don't need as good a balun to stop radiation back down your coax. Doesn't radiate along your boom. So in a way it's self-balancing. Some people might say it's not. It works.
It works.
It works. And it translated to the real world.
Cool. Good stuff.
And then I built the 6 metre version, which is pretty quiet for where I live, it's pretty quiet. Yeah. And I've got a blog, so all the details, except for the dimensions, are on the blog. So I might even write an AR article for that too. Someone can build it.
Love it.
Someone can build it, see if it works. Yeah. And they stack well too. They stack at 2.4 metres. 2.3, 2.4 metres vertically.
2 metres.
Yeah. Horizontally, might be 2 metres vertically and 2.3 horizontally. I made the model. It's actually quite a nice pattern. The lobes are right down. Right down. You do lose, because of suppressed side lobes, you do lose a bit of gain. That's the only thing. But the main goal with this antenna was sporadic edge, which I don't really need a lot of gain for. So I wasn't too concerned about it. Half a dB for saving 5 or 6 dB off the side of the antenna for a noise. Win-win.
Do you measure your noise with reference to a dummy load?
I measured my noise in reference to what I had before.
Right.
I haven't done any sun noise or anything sort of, technical. I just knew that I had the problem in the ZL direction, and now I don't have the problem in the ZL
For
direction.
instance, on 6 metres, I get 18 dB of noise compared to a 50 ohm load.
Oh, okay, yep.
Because I see the whole of Hobart's
Yeah.
noise in front of me.
Yeah, well, I could definitely do that and see what the difference is.
Yeah.
Because you're sort of beaming over Hobart, aren't you? So it's, yeah. One thing that the LFA does do is it also suppresses in the vertical plane. It does suppress the lobes there. So that's mainly for if your antenna's above your shack, picking up noise from down in your shack from houses that are underneath it.
Yeah.
But I don't know whether it'll fix noise issues that have been in Joe built one of these, a 2 metre one. And because he's got the same problem, looks over Launceston, and he didn't see any difference.
No, because it's still within the beam.
But if you've got noise issues off to, because the issue that I had towards the ZL direction was a Tassel factory, I think, and it was about 2 kilometres away. And every time I beamed towards it, like Nick, ZL1IU, I worked him December, I think, January, December, but I could only just hear him over the noise. It was impossible. Now there's no noise in that direction. So either my pattern's completely messed up and it's pointing somewhere else,
All the
or
antennas are dead short.
all the antennas. Well, no, we know that the antenna works. I've tested that. So,
Fantastic.
yeah.
Good stuff. Thank you very much, Hayden.
That's what I've been doing.
Well, I'm sure there's some people who want to see the remoting box.
We should see if we can get someone on
Yeah,
that.
yeah,
We'll see
yeah.
if we can get someone on.
Grab a tea or coffee, or and have a look up close and personal.
Very